There's costs people don't see of leaving things alone. 35% of the demand of platinum and palladium comes from recycled sources. Mining is not able to continue to keep up with where the supply is required. So recycling has to increase. We like to say we regenerate our material. We're not just recyclers, we're regenerators. The process is much harder to get correct than the chemistry. But life takes curves, and when you start telling people you're doing something new, it opens up the opportunities.
That is Don Weatherbee, CEO of Regenx Tech Corp in Alberta, Canada. As a trained accountant who ventured early into the resources industry, Don is at the forefront of sustainable innovation, closing the loop around environmentally responsible recovery of platinum group metals from end-of-life catalytic converters. He has over 20 years of experience across mining, construction, and technology sectors, and is finding new holistic ways to integrate the process and supply chains around these critical metals in an effort to create a better circular economy and sustainable supply worldwide. My name is Peter Marcus Bach, and this is the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to tackle the global challenges that our world is facing in their own unique ways. We reflect on the many out-of-the-box ways our guests have navigated the complexity and intricacies of the environment at the cutting edges of science, engineering, technology, and design. On today's show, Don and I delve deep into the world of platinum group metals recycling, or as he calls it, regeneration. We discuss his early days in mining and hear about Regenex's journey from junior exploration company to expert in sustainable metals recovery from catalytic converters, as well as the opportunities and challenges for critical metals in a world of evolving e-waste, automobiles, and resource scarcity. Detailed information is provided in the show notes over at peterandbach.com/podcast. Thank you for joining us today, and please enjoy the show. Don, welcome to the show.
Thanks. I'm excited to be here.
It's lovely to have you here. And when I was approached by you and your social media assistant, Kara, it was really exciting to be able to feature you on the show because we've had the topic that you're in, which is really around resources, metals, mining on the show once before. But you're in a very different kind of area that's really at the forefront of the buzzword that we call circular economy nowadays. And I'm really excited to get into some of these nitty-gritties.
Yeah, no, we really like dissecting what we do to let people understand it's a lot more complex than it initially seems from the outside.
On the one side, quite complex, and I think that's the beauty of it. And on the other side, seemingly simple when you think of the big picture. So lots of mysteries that we're revealing, but nevertheless, looking forward to getting into it. And you're based in Canada. It's been a while since I've been there, but you were just telling me before we started recording that it's a comfortable minus 28 degrees today.
Yeah, Celsius, which, just one for the American listeners. We're a little chilly here this week. The temperature's gone down, so a little bundled up today.
And Celsius, I did ask Fahrenheit. I'm not as familiar with all the different units, imperial and metric, but it's been featured a few times on the show already. And I think especially here, it's good to know both units going forward.
Yeah, it's something that we flip back and forth between units a lot when we're in Canada.
Definitely. I guess related to units are numbers. And that's something also close to your heart, because when I was looking up how you went into where you are now, which is Regenx, and we'll get into what that is in a minute, you came from the accounting side. So how did you go from accounting into the resources industry?
So I joined resources industry straight out of school. I graduated as an accounting degree from university and joined a coal mining company in their accounting department and worked towards my designation. So I spent about 7 years in a coal mining company, working my way through various different positions, including being an on-site controller of a mine site. So I spent nearly 2 years out in the wilderness, actually at a mine site. Then moved into oil sands mining, which is up in northern Alberta, where they're turning sandy oil that they get from the ground into petroleum.
Oh, very interesting. So from coal, I guess, to sandy oil, and in a way, eventually to metals through a few steps, I guess, and hoops.
Yeah, there's been a couple of hoops with the path that Regenx has taken.
And accounting, I mean, when I think accounting, it's usually, working with balance sheets and making sure that the finances are in order. I mean, was there anything in depth about that, or were you hoping to go in that direction, or what inspired accounting in the first place?
So what inspired accounting was a little bit of wanting to be in business and wanting to understand business. And accounting, although it seems like a silo, is one of the rare places where you can look at a whole business holistically. because everything touches the numbers. You said about the balance sheet. Well, if you want to understand the numbers, you have to be able to pull apart the company. And you have to understand how the whole company works and what the processes are. To be really good finance person, you have to be a really good operations focused, because you can simply sit there in a room and plug numbers into the spreadsheet and have it spit out. But that's not going to be a value add. It's not going to allow you to be more than just a beankeeper. So I always took it in as an opportunity to learn a business. And what's funny is you can push yourself into places because the numbers touch everything, like I said, and people don't understand why you shouldn't be in a room, because you can always make it that you need to understand more to be able to do your job effectively.
That's very clever. And actually, now that you mention it, when I went to university a few years ago, well, it's already been a decade ago, I always thought, okay, accounting, there's a lot of finance involved, and a lot of these terms always went past my head. But being in the environmental field over the years, I started to see these terms actually crop up in the work that I'm doing. So when we think about planning, we think about land use budgets, and we try to subdivide a piece of land into different sections, and it has to all add up in the end to 100% of all the area accounted for. Same with water. When we talk about water flows, we also talk about the word accounting for water flows. So it's quite interesting to see how this kind of terminology, and I guess the thinking as well, can be applied to many other fields, as you mentioned, in this case the business, understanding the different flows of processes, and then I guess the dollar values attached to them as well, and as a way of quantification.
Yeah, and I also think of it as the other way too, is that if you're good at your job in the accounting finance area, you've got to be a translator and be able to translate numbers to operations to make sure that they understand how their actions affect financially. And like you said, most of the terms go over people's heads, and it shouldn't be like that.
Yeah.
Just because the term's there doesn't mean you can't explain it and translate it to something that means something to them on how they're doing their job.
Very true. And so straight into mining from accounting, but armed with that interesting way of thinking. And I always think, we go to further studies to learn a way of thinking. But yeah, you were then exposed to the world of mining. And I know Canada is a pretty big country as far as mining is concerned. I remember embarking on some work where we've looked at the comparisons between Australia and Canada. But one particular aspect is this idea of mines. They have a certain lifespan, and we've had this featured on the show before on episode 17 with Mohan Yalishetty, who talked about mines ending the end of their life cycle and what to do with them. In what extent did you encounter these kinds of occurrences where mines then had to be dealt with post-operations?
I did actually have a lot of that. When I was working, I said I worked out at a site. That site was in the foothills of the Canadian Rockies. And there was 4 active mines in the area. And we were looking at, well, what's the next step for one of these mines? And we had to make the decision to shut it down because the drilling we were doing on the expansion areas was showing that the resource just wasn't there. So we made the difficult decision to say, no, this mine's going to come to its end of its life. So how do we start preparing for the end of life of that mine? And there's a lot involved in that. And the mining companies do keep that a lot of top to mind. And the coal mine I was working at, even while we were mining, the reclamation of the mine is happening at the same time. They were creating new environmental areas, landscapes, the whole time that the mine was active.
So in a way, it happens at the same time, simultaneously. I guess you're being prepared for it as the mining is ongoing.
Yeah, and so every mine has a social license to operate, and you can't just leave it for the end. You have to make effective use of the territory. And some of it naturally happens because as you move, it's all about moving dirt and piece. So you have to find spots to put the new dirt that you're doing. So it makes a lot of sense to start filling back in the areas that you've previously went through. So it's both a social license and it's also good economics to just continue to do the work as you're going along.
Very interesting. Yeah, we talked about many different examples of what you can do with them, but I guess simply providing those environmental areas would be, in a way, one of the, the immediate cost-effective benefits because it reduces the environmental impact to begin with.
Yeah, and you always want to reduce it because as you're mining, you have to maintain these areas that have been previously mined. pumping and monitoring and all those. So if you can get the site reclaimed while you're doing it, makes a lot of economic sense to do it, because there's costs people don't see of leaving things alone.
It's also a cost of time. Like if you're able to do it in parallel, then you're saving that entire time for rehabilitation works at the end, because not much of it is left.
Well, and it's cheaper to do. You've got all the infrastructure. You spend more money at the end when you're doing smaller amount of things than you do adding a project to the bigger picture.
Now, very, very fascinating. I mean, my level of experience in mining has only been what I've seen on maps. I have yet to go and visit a proper mine site or even a quarry. And I'm really looking forward from all the different information and literature and the conversations I've been having. So very, very excited at some point to go out there and have a look, perhaps on one of my trips to Canada or Australia in the future.
They're awe-inspiring when you look at what we're actually able to do and how it actually can be reclaimed at the same time. And
just the size of the equipment on site is just mind-boggling.
Yeah, when we were in the oil sands part I was in, my company had 320-ton trucks. So each load carried 320 tons of material, which is sort of like sitting in the second-story window of your house and driving your house around the property.
Every time I hear the word 300 and above tons, I think of a math book I had, I think in 6th grade, where they had pictures of comparisons, and it was a jumbo jet that was used as the 300-something ton example. So that's always the picture I default to when I hear numbers of that size, and that's pretty insane. But you went from coal to oil and to metals now. And another quote that I thought immediately connected me with the topic was something that my previous guest Mohan mentioned on the show, which was that metals are infinitely recyclable. And the first time we met, you had a very interesting commentary to that particular statement.
Yeah, so we like to say we regenerate our material. We're not just recyclers, we're regenerators, which the kernel of our name, Regenx, it's playing on this regeneration. And it's because when you look at traditional recycling, most recycling is downcycling. Example is your white piece of paper. You take that white piece of paper and recycle it. It's not coming back as white paper. It's coming back as a brown cardboard or something. And so it keeps moving down the value chain, going from the pristine original product to worse and worse quality pieces.
Interesting.
In metals, when we recycle a metal, we return it to its pure raw state. So it is exactly the same as if it had come and been processed out of a mine. So that's the part where it talks about it's infinitely recyclable, because there is no end of the piece. It's always a restart. And that's where you'd mentioned circular economy. That's how our part of it is truly a circular economy, because you're returning the product to something that's exactly what it could have been the first time through.
And that's why regeneration makes sense, because you said downcycling. I've heard of the word upcycling in the context of circular economy before, where I think it was an example of someone using an egg carton as a flower pot or growing pots for plants. So I guess it's taking the product and doing something different with it. But neither of them kind of fit what you've described, which is trying to restore that purity of metals, and hence the regeneration then coming into play.
Yeah, and that's what we're proud of, is that you're replacing the original and you're not having to find a new use.
Different way of looking at things in the end that I guess sort of highlight the subtle nuances between different kinds of words that may be used quite interchangeably nowadays in sustainability talk as well.
Yeah, and that's where we like to be a little more precise to make sure people understand the impact that we're actually having.
Yeah, no, fascinating. So studying accounting at the University of Alberta, which you finished in 1994, then 7 years at a coal mining company, Lusker Limited, as the financial accountant. And from there, you moved on for 14 years at KMC Mining, and then proceeded from there to Regenx.
Yeah, that's the trail I've taken.
And in a way, we can also trace from coal to oil to metals. And I guess that's where you are now, CEO of Regenx since last year.
Yeah, since August last year, our former CEO retired, moved on to just being the chairman, and I moved into the CEO role at that point in time.
That's amazing. And you've also been with Regenx for quite some time, but the company itself has had a very interesting history as well. Could you tell me a bit about that?
Sure. So the company, when I started in 2015, was a traditional junior exploration company. And so I was joining another mining company. So I thought I was staying in the mining world when I joined. And a junior exploration company, for some people who don't know, there's lots of them in the world. And what they do is they go out and they look for properties that may have resources in them. They find these properties and then they do some exploration work on the properties to try to determine how much of the resource is there.
So like geological surveys,
Drilling programs,
yep.
those types of things to try to prove up that there is a resource there. And then from that part of their life, they either try to develop that mine into an operating entity or look to sell the property to a larger entity who will then develop the mine.
Ah, interesting.
And so when I started, the company had just sold one of its properties and still had one. And I thought I was joining to help develop that iron ore project into an operating entity.
Mm-hmm.
But we were also took that time with where we had and said, is junior exploration the right place to be? The economics and the raising of capital at that point in time weren't very favorable for a junior explorer. And what we were able to do while doing that evaluation was found a material processing private company and purchased that. So that brought us into the technology world. And the processing technology was initially meant to go and look at old gold tailings deposits and reprocess them and take out the gold that wasn't economic to extract 100 years ago with the new technology.
Interesting. So bringing in yet another potential, I guess, literal gold mine, that we are also encountering nowadays. Other than mine closures, there's a lot of the tailings which, just haven't been, as you just said, economical to extract from the material that is then dug out of these mines. And now, I guess, with the advancements of technology, with the hardware we have, we're able to go back to these tailings and to then actually obtain more out of it, be it gold, be it other kinds of critical minerals or precious metals.
Yeah, and that was what we were intending to do. But life takes curves, and when you start telling people you're doing something new, it opens up the opportunities. And the first one we had was we approached about saying, well, you got processing technology. Can it work on e-waste? So we started down going, well, can we modify to extract the precious metals from e-waste? And we did that for a little bit. And while we were doing that, we also got approached by a group, Davis Recycling, and said they had an opportunity for catalytic converters in a place that nobody is touching. Could your process work on that? So in 2020, we started lab work and testing to see could our process work for catalytic converters. And we're off to the races, and that's where we're focused at this point in time.
And in a way, the biggest input to the technology you have at Regenx to then obtain precious metals or critical metals, as we also call them, that can either be used in the same piece of technology again or in some up and coming automobile technologies, but also, I guess, other devices if needed as well.
Yeah. And mention that is the future for especially what we call PGMs, platinum group metals, which includes, from our perspective, platinum and palladium. Hydrogen fuel cells in the new future are large users of platinum, and they're expected to be a large user of platinum. And they're used for their anodes to create the electric current that separates out the hydrogen.
Interesting. Yeah, because of their material properties, they're very desirable and therefore would be of use, not just in, I guess, catalytic converters, or I think smartphones use them as well, but probably in much lesser amounts.
Much lesser amounts, but yeah. Anything with an electric current potentially uses the platinum group metals.
That's very interesting, but also very good for what you do then with the recovered metals or the regenerated metals as a result of it.
Yeah.
But I guess coming to catalytic converters, and that's really, the input to the whole process. Let's do a bit of 101. For me, I remember studying catalytic converters back in high school. It was in textbook material used in cars to try and reduce the smog output. I think they had different versions, but I think since the mid-1970s, they started putting them on cars. I guess there's different versions that work with converting carbon monoxide and a few other nasties into carbon dioxide and water, just to reduce the air pollution. Am I sort of remembering my high school studies well?
You're remembering it quite well. So the fundamental is that a catalytic converter is on the underside of your car, looks a lot like a muffler. And what it is, inside that steel cage, is a honeycomb of material.
Yep.
And that honeycomb is coated with your platinum group metals. And the concept is the platinum group metals are oxidizers.
Mm-hmm.
And so as the dirty air from your engine flows over these surfaces, it creates a reaction and oxidizes the gases. And that oxidation does what you said, takes the carbon monoxide and the smog gases and creates less harmful gases. Yeah. Not saying that they're perfect, because we fixed the smog problem, but created a lot more CO2.
Yeah, they always say that one problem leads to another. And it makes people obviously jump for joy that support other kinds of mobility options, because then they start saying, well, we have to deal with the source in the first place. Whether you see this in city planning or you see this in automobile technology, but we have to work with what we have. And I guess there's a balance between a reactive and a proactive approach.
Yeah. And yes, the CO2 has become an issue, but I mean, you remember from your thing, the cities were choking. And if we hadn't put the emissions controls in, we'd already be in a much more dire state than we currently are.
No, definitely. And so catalytic converters became mainstay. I guess there's two types, one for gasoline cars, one for diesel cars, which is quite important as far as Regenx's technology is concerned. And I suppose, that with it has very different, constructions or processes. What are the key features here? So
the key feature is that diesel engines run much hotter. Mm-hmm. Their gases are a lot hotter than a gasoline part. Plus, they also have processes called regeneration, where they burn all the soots that they get. Mm-hmm. For that reason, the honeycomb in a gasoline engine was traditionally built from a ceramic.
Okay.
And so that honeycomb ceramic was what it is. You put that into the diesel, and it starts to degrade.
Oh.
So it needed a much more robust substructure. And they've built them now out of silicon carbide. So that silicon carbide is a much more robust substructure that allows the extra heat to be used. So where does that become an issue? Well, the dominant way of recycling historically has focused on gasoline, and it's smelting.
Okay.
So fundamentally, you put the material into a large furnace and melt it. Well, if you start putting silicon carbide in instead of ceramic, the furnaces start working a lot less efficiently.
Or the energy required to melt it,
energy
to get it
required,
to temperatures.
Or if you've got mixed materials, you get hot spots and all those types of things, which can cause issues around safety.
Oh, okay,
so the smelters have historically said, no, we're not taking the silicon carbide, which is where Davis had come to us and said, well, there's this niche of product that's increasing in the streams, but the end recycler didn't want to use it. So that's where our niche comes in, is taking stuff that doesn't fit the traditional stream, but is growing in content.
So end-of-life catalytic converters, they have to be recycled in some form, or at least dismantled. And in this case, the metals regenerated so that you can create new ones, or the fuel cells you mentioned, or any other kinds of needs for these metals. But the diesel ones are just much harder to deal with, and hence the opportunity that you have.
That's exactly where we came into the marketplace.
As far as I understand, Regenx's technology does not actually work with smelting. What do you do instead to get these metals back from the catalytic converters?
So two primary ways to get the metals back. One is the fire, which is the smelting. Mm-hmm. The other is what we do. It's called hydrometallurgy.
Hydrometallurgy. Interesting.
And what it is a fancy word to say it's in a liquid. So we do it as a chemical leach.
Mm-hmm.
So we put the material into a chemistry leach. So that strips the precious metals off the substrate,
okay,
and puts it into a liquid form.
Uh-huh.
We then take and separate that liquid from the feedstock, so a solid liquid separation. That then liquid, we use another chemical process to drop the precious metals back to a solid state.
Oh, interesting.
And so that's our process of stripping away and then reconstituting the metal to get it free from the substrates.
And so this does not involve actual smelting. This is really just working with, the chemical reactions of what you get, which I believe is a shredded down version of a catalytic converter, literally shredded.
Well, we start with a powderized catalytic converter.
Powderized, even.
And then separate out the silicon carbide and then the precious metals. And so we've got a dirty part because it's got other parts in. And then we just send it to a refiner who makes pure platinum and palladium.
Yeah, I guess once they have a lot of the concentrate, they can then go through that one last step to then create the raw material for use.
Yes.
Now, very interesting. I guess one thing that always begs to ask, especially when we're talking circular economy, when we're talking about, CO2, is how does this compare in terms of emissions to the traditional process?
So we compare to two factors. One is the mining itself, and we're like 99% less water, energy, all those pieces against the mining. Plus, we don't have the ecological footprint that we don't have to open up dirt to do it. Our process is done in a warehouse type facility.
Self-contained, I guess.
Self-contained.
Controlled.
Comparing against a smelter releases about 1,500 kilograms of CO2 for every ton that they process.
Mm-hmm.
So, and our process is negligible.
So in a way, closed process, able to replicate it because you build a facility that can run through the different unit operations of this entire recycling process.
Yeah. And so one of our keys to our success has been, we had that processing background, like we talked about. So we added chemistry to a process. Most of the other people have come from the chemistry side. And what we found is that the process is much harder to get correct than the chemistry.
Yeah.
Because it's always easier to make the reaction happen. But like I talked about, how we're changing states of the material and we're moving it from station to station. So that physics is rarely where all the work needs to be done to get it to work at a commercial scale. Like to say, movement of material is really simple in a lab or in a pilot plant, because the main piece that you have for movement is pumping. And you can never get a pump small enough to scale. And so whenever you're in a small scale, your pumps brute force every problem away. But when you get up to scale, you can't brute force pumping. You've got to have it work efficiently, because pumping becomes exponential in cost. So you have to understand how you're moving material effectively to make the whole process work.
I mean, I was literally visualizing someone doing this process by hand in the lab as you were explaining this, and just thinking the sheer scaling up of such a process must have been quite challenging, and I guess can be the bottleneck for many innovations that work in the lab but just don't function at scale.
Yeah, and that's where 99% of inventions fail. Is they're great in the lab, but getting them to commercial scale, there's all kinds of unforeseen pieces. And the worst piece of that is that you don't know whether it will actually work until you're getting to size. Because like I said, all the testing you do doesn't necessarily move to that next step for process material movement.
No, that is very true. Yeah.
And you can do all the theoretical, all the smaller scale, but you don't know until you are in the weeds of a commercial size that it's actually going to work like it was intended to.
Or be as cost effective as initially estimated as well.
Yes.
Yeah. I guess to illustrate the volume differences. I mean, when I'm thinking lab, you're probably working with, beakers, maybe, I don't know, half a liter or maybe a slightly bigger pilot plant, but what kinds of volumes are you shifting around in a normal process operation on a daily basis when you're doing this at scale?
Yeah, so our pilot plant, we had it designed to do 25 kilogram in a batch.
Okay. Yeah.
Our new process, we're doing 4,000 pounds.
Oh, geez. Wait.
In a batch.
And harking back to the fun bits of how we started this episode, you're challenging me nicely with my imperial and metric conversions.
So 4,000 pounds, there's about 2,000 pounds in a ton.
Yeah. So 1.8 tons based on the conversion. Yep. So that's a nice scale up.
Nice scale up. And that's where I'm talking about pumping. And when we're talking that's just the solid material that's going in.
Yep.
You've got, what we're looking at is saying we've got about 2.5 times of liquids with that.
Yeah, because that has to then be transformed into that leachate, as you mentioned.
Yeah. So you're talking thousands of gallons of liquid that's being moved around in your process.
No, that's it's definitely taken, I guess, quite a bit of development to then get you to that stage, but that's where you are now. So Regenx has a fully operational plant, as far as I understand.
Yeah. We had to move locations, so we're restarting it at this point in time. But we're producing revenue from our plant here at this point in time. So,
And as far as I understand, the plant, you call it Module 1, it's in Eastern Tennessee.
yes. So because you talk about scale up, we wanted to build in modules so that we picked an economic size that would work for the process, and then thought we'd add lines. So more modules into the facility to be able to increase production.
Now, that's how I also think about it in terms of, in the water sector, when we think wastewater treatment plants, if we need to scale it up, we sometimes add parallel streams. Also, I guess, helps with the maintenance of the plant. If you have parallel lines, you can shut down one to maintain it while the other one still runs.
Yeah, exactly what our thinking was, is that you're going to have to maintain it. So instead of turning the whole plant off, you can use different lines and reroute some of the material if you've got any issues.
Yeah, no, that's fascinating. And so that's now quite operational. And you've also got this partnership with Davis Recycling, as you mentioned, who's supplying you that initial material, these diesel catalytic converters. So
yeah, that was one of the other big lessons we learned in eWaste was supply chain management. Is that we are experts in our process, but we are not experts in the supply chain. So if we were to move down this path, we were only going to move down this path knowing we had a relationship with a supply chain expert. Because it's one thing to be able to do something, but you need to be able to get a ready stream of product at the right pricing to be able to make it economic. So that's where the relationship with Davis was really important to our decisions to move forward.
And a gold mine, I guess, pun intended.
Yes.
Yeah, but I was going to ask about the e-waste, because you mentioned that at the start. And when I think of, these kinds of recyclings, the number of metals that go into just our smartphones is ridiculous. And I also remember seeing, and I thought it was really cool at the time, some of these machines that you can just put in a smartphone and it crushes the thing and separates out all the metals for you, almost like it does it for you, kind of serves it to you on a silver platter. Literally. But what were the potentials of e-waste? Was it just a supply problem, or is it harder to do with e-waste in general?
It's two parts.
Yeah.
What you talk about is true on a very small scale. Again, that little process that you're talking about that separates out, that's easy to do with 1 and 2 type thing, but not on a commercial scale. Because what we like about the catalytic converters is that they're pretty much homogenized. That it's going to be the same stuff going through.
Yeah.
Your e-waste is vastly different, and vastly different between even just different types of phones. And you've got a lot of what we call junk in there, like your organics and pieces like that. So really, when you get down to the nitty gritty, is that grinding up isn't as effective as it might first seem, because what you've got is a lot of soft metals like copper. And as you grind them up, you don't notice it if you're making big chunks. But when you're trying to get down to the very, very small particles, coppers and soft metals don't grind, don't turn into a powder. They just, you can go them through and they get smaller, but they start turning into balls and bigger pieces. And so it becomes harder to get them to separate. And because you've got such a mixture, some of the cheapest metals are things that your leaches go after first.
Yes, not ideal.
So you're spending a lot of money trying to chemically separate out these pieces, and you're separating out the cheapest metals first. And so it's a law of diminishing returns trying to go after the more precious metals with your process. So you have to figure out ways to start separating out the different pieces.
Interesting.
And some of that's gravity and densities and stuff like that. But you lose some of your most precious because they're the smallest amounts in there. So that's what's made e-waste challenging. And that's where most of the times the e-waste, the best way is to put it into the furnace type thing, because it's easier once they're all melted to separate.
Perhaps it could be a combination of the smelting first and then, these chemical process thereafter. But I guess that has yet to be seen. Yeah.
And so there's always opportunities on how you look at it. But those were the challenges of e-waste. So what we had found when we were going through it was 1, the supply chain, and 2, the sheer amount of different types of metal in the process and figuring out how best to separate out those pieces.
I guess sometimes it's hard because there's not really a silver bullet for everything. And if you're dealing with too many things at once, it just makes things a lot more difficult.
Yeah. If all the conditions keep changing, it's really hard to get yourself set up to run effectively.
Yeah, no, that's true. So platinum, palladium, in a way, focusing on those two metals. And I was just actually checking the spot prices of platinum, palladium on the market. I was looking at a graph of the last 10 years. So, and this is a fun opportunity to go into units again. But
Sure.
it averages around, I think, $30K US dollars of platinum per kilogram or 950 per ounce. And palladium is slightly more valuable, so 32,000 US dollars per kilogram or 1,000 US dollars per ounce. And this is sort of the 10-year average. And gold is, I think, a bit higher from there, but they're quite valuable compared
They're quite
to
valuable.
silver, for example.
Yeah, and they're in that gold range. I mean, gold has been down to that level. More recently, it's up that. But palladium itself, back 2-3 years ago, was up in the $2,000 an ounce range.
Oh, wow.
So platinum has stayed around that 1,000 more recently. And part of it was the palladium declined a little bit with the thought that e-cars were coming and batteries were coming very fast.
Interesting.
And so if you think back the last 3 years or so, the hype on electric vehicle conversion was rampant. Oh, it's all going to be converted right away. Everybody's going to be riding a Tesla. But you've seen that adoption, especially in the US, drop a little bit. It's still coming and it's still going to go. But that concept that it was going to happen right away has sort of reduced, which at the time, about 80% of palladium goes into catalytic converters.
Yeah.
So the concept saying, well, catalytic converters are going away, sort of dropped the future value of palladium.
Because of that 80%.
Yeah. Looking, saying, oh, no, there's not going to be any market. But when you start looking at it and going, okay, where is this actually going? It starts to change the dynamics, and you're starting to see the aggressive projections have fallen off.
Yeah.
And we're getting down to more of the bear-ish projections. So the stagger out time is going to increase, which means more internal combustion engines for longer period of time.
Yeah.
And for our side, the diesels were the last to get catalytic converters, and they'll be the last to convert.
Ah, interesting.
Mainly because think about trucking.
Okay. Most trucks have diesel engines. So, yeah.
And if you think about trucking, there's two key metrics to the trucking economics. How much weight can you haul? And how long does it take you to get someplace?
Logistics-wise, time is money. Yep.
Time is money. So if you think about refueling on the longer hauls, well, it's a small amount of time to fill up at a gas station, a diesel station.
Yeah.
But when you have to recharge that battery, that's going to, even with fast charging, these are larger and larger batteries that are going to take more and more time. So there has to be more breaks in your haul.
So in a way, the economic feasibility just doesn't make sense because you're losing time just charging and you don't have fast enough charging batteries.
Yeah. So those are some of the current logistics issues that you have. And also, most of the times if you're hauling long distance, you're hauling it through a lot less populated areas.
Yeah, that's true. So likelihood of charges,
infrastructure ways.
Yep. No, very interesting way of putting it. And actually, a way to see how technology might progress given how we operate on a daily basis with our logistics, with our infrastructures.
Yeah. So not saying they're not going to change, not going to move into this, but there's a lot longer path than was originally thought.
Yeah.
And so that means that there are going to be more diesel engines for longer periods of time.
And I suppose certain cars will still have diesel engines because people enjoy long distance driving or just more power in their cars.
Well, and that's the other side of the cars, is that the early adoption of EV vehicles has been city drivers, which they're perfect for.
Yeah.
Short distance, that you've got a lot of downtime for them, a lot of time to charge. But you start moving out to rural, where there is a lot less infrastructure that's attuned to that, then it becomes less and less of a great to have.
All of a sudden, you start to worry about the mileage that a single charge can bring you.
Yeah.
And especially when you're out in the countryside. I've seen that with the Australian countryside as well, being in small towns every now and then, visiting. And it's just the sheer distances and the amount you're driving can be quite substantial compared to city driving.
And plus the infrastructure to be able to get the charge is going to be a challenge.
No, indeed. And I suppose, you've got a market that will take a while to go away, because recycling the platinum palladium from these catalytic converters can then be used in new catalytic converters, but also hydrogen fuel cells.
Yes.
Where I was going with the market prices as well is just when I think of, let's just say they're both roughly $1,000 US per ounce. I mean, you were recycling 4,000 pounds of catalytic converter feedstock. I mean, how much metal are you winning from that one process? How much metals are you gaining?
It varies.
Yeah.
And that's the hardest question we always have to answer is, well, how much is in a pound? Every catalytic converter pretty much is different.
Yeah.
Every manufacturer, they're all trying to minimize the amount. So they keep building different structures to help maximize the use of it, which then changes the amount of platinum and palladium that are in them. And then also layer on top of that, regulations keep changing. So new regulations come in, that changes what the loadings are on them. And then the manufacturer learns a little bit and changes and says, well, we can do this to meet regulations. And so every time there's a model difference, there is a different amount of loading in it. And it also changes on, well, because we're doing 4,000 pounds, it's not consistent on what the feed we're getting. But it can range from, 200 parts per million. So really you're looking, and then upwards to 2,000, 2,500 type parts per million.
So quite concentrated in the end. Decent amounts. But I guess all in all, when you think of, these prices, I suppose the market yet to come or the potential feedstock yet to come, when you just think about how many cars are out there, it's got to be ranging in the millions, if not, hundreds
in billions.
Of millions. Billions even.
Yeah, there is 27 million vehicles scrapped every year.
Okay, that's not a small amount.
Not a small amount.
So, I guess listeners go and just let your mind be blown by numbers just from that one beginning. And so, platinum, palladium, if we are able to regenerate them from catalytic converters, do we still actually try to obtain them, through normal processes of mining, or, are we running out of supplies worldwide?
So right now, about 35% of the demand comes from recycled sources.
Okay.
So we continue to have to mine, but also on the fact that over the last 8 years, there's been a supply deficit of about 259,000 ounces.
Okay.
Every year. Not a small amount. So we have to continue to mine in the near term. But long term, mining is not going to, well, we know mining right now can't meet the demand. And there isn't a lot of excess mining to bring on stream. And where the current mining is 80% of platinum and palladium come out of either Russia or South Africa. So both of those have geopolitical instabilities. So counting on either of those areas to produce more is naive at best.
So we can't rely on just two locations in the world, and it's not as ubiquitous, I guess, as it was before.
Mining is not able to continue to keep up with where the supply is required. So recycling has to increase. If demand is going to increase, even if demand stays where it is, recycling has to increase.
Enter Regenx having a much bigger role to play, I guess, in the future to come.
Yeah. And also, I'll put on that is recycling through smelters is also harder to increase, because on a regulatory basis, putting a big smelting furnace in an area is never an easy add.
I guess that may yield quite a bit of resistance as well in terms of environmental impact and many other factors.
Yes.
And so you've got the plant in Eastern Tennessee now, and what's in store in the future? Are you going to be doing some production in Europe or in Asia or in other continents?
So we're a stage up. Our plan is to take the Tennessee plant. We got module 1, expand. Our plans are about 4 modules.
Okay.
And that sort of covers a lot of the eastern seaboard of the U.S. There's a large population of vehicles in the western side of the U.S., so our concept would be a secondary location in the U.S. Then it would be looking internationally. And we'd probably do internationally based on partnerships, alliances, joint ventures, because that's a better way to enter a foreign market, especially in an area as complex as we are, where you're also looking at supply chain and regulations. Trying to go it alone would probably be filled with problems, let's just say.
I guess they say it's never wise to go it alone. You want to work with someone, much like Davis Recycling, who are able to help you with the supply chain. You might find that similar story in Europe or in Asia as well.
Yeah. So that's how we would approach those markets.
And is there a strategy based around, I guess, the key continents where mobility, is heavily based around the car? I'm just thinking cities that were designed to be more sprawled and where automobile purchases are high.
Well, yeah, I mean, you'd be fundamentally is Europe, mainly because their recycling ethos is much higher in that area. And they have a large car population. Then it's Asia. Asia is just because of the size there, the distances, and the growing rate of auto increasing is phenomenal over that side.
Yeah, I always remember growing up in Asia myself. In the early days, you would always see minimal cars, lots of bicycles, motorcycles, and then over time, they all got replaced by cars. So it's crazy to see how denser the cities have become, how much more active in terms of car use the cities have become. And yeah, we're sort of at that cusp now of trying to rethink what mobility means with the rise of EVs, alternative transport methods. But I guess, the technology is always there, and there's always going to be some need to regenerate the metals from, be it catalytic converters or who knows in future, fuel cells maybe.
And just also on the fact, like the Chinese have implemented a lot of the air emissions regulations too. So the use of catalytic converters has increased substantially in the Chinese market.
It's amazing to see the interconnections, between regulations, even, remotely related to mobility and, what opportunities they are and exist as well for the future.
The only constant is change.
Yeah, no, that's true. Don, it's been fascinating listening to the whole story around, how you went from accounting into understanding business processes to Regenx, the process that you're working with to really win back these precious metals that can help us change the world as well, and closing that loop, that circular loop as well. And like I do with every guest, I'd love to get into asking you a few more questions about yourself so that listeners can get to know a lot more about you, the inspiration you have, and what you bring to really shaping Regenx's next few decades even.
Sure thing.
And so a lot of what you've showed us, the chemistry that you use instead of smelting and targeting catalytic converters, being very strategic about it, it comes down to that word innovation as well. So in your view, what does the word innovation truly mean? And how has it shaped the way you approach challenges and opportunities in your work?
So innovation to me means opportunity. And so how do you lever opportunities and how do you change things to capture an opportunity? So whether it's through a process change or technology change or a mindset change, those are innovation. And you only ever get innovation because you're trying to capture an opportunity.
That's an interesting way of thinking about it. Mindset change even. I guess that makes sense because it's about a way of doing things. It's also about changing the way we do the day-to-day. Thinking differently.
And for myself, I talked about my history and that translating between groups and that is that as an outsider, you can take the opportunity to say, explain it to me because I don't understand. And it allows them to talk in a different way and explain what they're doing, which sometimes gives them a mindset change and lets them see opportunities just because they had to explain it in a different manner than they normally do when they're talking to people who are fully steeped in the way they do things.
No, that's very interesting. And thinking about it, when you came out of accounting, it was a lot around finances and understanding some basic, processes and how they interlinked in a business. But when you then go into a very specific type of field like mining, the first thing I guess you have to do is to understand how the processes work. And the only way to do that is to really get your peers within the company to explain it to you. So I guess that's a fascinating opportunity in itself.
Yeah, there is never a bad question.
I think that too.
And you never feel stupid about asking stuff that you don't know because you may not be the only person who doesn't know.
That's true. In a way, the curiosity and the courage to ask it gives you the reward in the end for the new knowledge you gain, which is the answer tailored to you.
Yes.
Was there a key moment, person or book or event that completely changed the course of your career or your mindset?
So my career, I wouldn't say there's key moments or that. It's just pieces have fallen in. And for a while, it was being exposed to a bunch of once-in-a-lifetime things happening in the businesses that I was with, that you are dropped into a sink or swim piece because something's radically changed.
Oh, wow.
One example is when I was with Lusgar, the coal mining company. Well, it was a family-run company for decades. And the family decided, well, it was time to get out. So we dropped into doing an IPO that was being done in a 90-day period.
Oh.
So you were dropped in that this was a complete change to the business model, all these pieces, and you're just saying, okay, how do we get through? So that's a once in a lifetime thing. And you think, okay, I won't have much exciting to do. The very next year, we did a hostile takeover of one of the largest alternative companies.
Oh, wow.
So you're dropped in, and these were at young parts of my career. So you got decades worth of experience in relatively short periods of time. And so it just accelerated your learning. And then many you understand that you have to be ready for all kinds of changes, and you're just going to get thrown into stuff. So you might as well figure out how to make it happen and not worry that you don't know exactly what you're supposed to do.
Never a dull moment indeed. And yeah, as you said, change is the only constant. And in a way, from what I'm hearing, it's also you have to be ready to embrace the change and to just face it head on.
Yeah. And that's a key, like I said, mindset change is saying, okay, stuff's going to happen. So you can either bemoan it or say, okay, let's figure out how to use this as an opportunity, how to use it as a way to move forward and learn something.
I guess they also say when you're faced with challenges or things don't go the way you expect, it's looking for the silver lining, just to put it in a completely different way.
Yes.
There's another famous saying. So many key moments, key events that I guess, you, as they progressed from one to the next, you face them with even more confidence and even more determination every time it came to you.
Yeah. And so it wasn't any key thing. It was just a set of building blocks that began to give you more confidence and give you more opportunities, and you move forward in those types of endeavors.
And I guess it's never to be hesitant to face these moments, because once you go through it, the next time you face it, it's even less complex or just easier to deal with at a, psychological level.
Yes.
And so being CEO of Regenx now, I guess time management becomes a very important aspect. So I'd be very curious to hear what tips and strategies can you offer in terms of time management? I mean, how do you maintain a balance between your professional and your personal time?
Well, part of it's making time. I'm over 50 and I'm still playing beer league, we call it, but it is competitive hockey.
Oh.
So it's getting out to make sure that you have activities to keep yourself centered and refreshed. A lot of times being able to be active and physical activity is a great way to make sure that you're de-stressed and you got yourself a nice recharge of being able to think. The other side is you're only as good as your people. And trusting your people and having them do the work, making sure you're overseeing it and understanding it, but you can't do everything. And if you try, you're going to fail.
Yeah.
So you've got to find the right people. You got to put them in places for them to do good work, and you've got to trust that they will do the work. And the more you try to micromanage, the more you gum up the works.
Yeah, I guess it's, teamwork. Doesn't matter whether you're working in a strict hierarchy or in a, as they call it, flat hierarchy as well. But it's about being able to understand each other's strengths and to leverage it. And as you said, trust that everyone's in it. They know what their mission is, or at least their day-to-day objective, and that they'll deliver on that.
Yeah, and I see my role a lot is even back to the accounting side of translating and understanding is sort of getting people to explain why we're doing stuff and getting a second look at them to say, okay, procedure-wise, you're setting up this, why? And okay, so what's you're trying to accomplish with that setup? Walk me through. And if they're walking you through, that all of a sudden highlights areas of concern or areas that they haven't thought of yet that you can bring to the attention to say, okay, no, we've got to focus on this. If we don't do this, it's not going to succeed. So it's making sure that you are interfacing so that you understand what is trying to be accomplished and is it being done in the best way.
And if you can do that successfully, then in a way it removes a lot of that burden on your own thoughts and allows you to then pursue, I guess, the balance as well, as you mentioned with the hockey.
Yes.
Which is very fascinating. I mean, I've not played it. I've seen it many times. Ice hockey or just hockey where you're running around on the field?
Ice hockey. Ice hockey.
Yeah. I figured given you're in Canada. I had to be sure. I've seen both versions. So, no, fascinating.
Never played the field hockey.
Yeah. I've always seen hockey as one where you're on the ice. So I'm with you there. So definitely. But at some point, I'm sure we'll have a guest on the show who probably plays field hockey, and I will definitely ask them to give us their opinion as well. So looking forward to that moment in time. What is your favorite childhood memory?
So I spent a lot of my childhood as a military kid, a base brat. And so we transferred. Like we were switching continents every 4 years growing up.
Oh, wow.
And so what it is, it isn't one memory. It's the whole concept of how I grew up, of change and how you can restart and reintegrate into places, and the learning you get from seeing different parts of the world, different perspectives, allowed you to be a lot more open to how things work. So I wouldn't say it's a memory, it's how I grew up is my favorite part of my childhood.
Interesting. Yeah, I mean, I switched a few places growing up as well, but it took me a while to begin that. And yeah, in a way, reflecting back on it, it really builds character, it builds resilience as well, it builds adaptability. But yeah, it's fascinating that in a way, that's what you remember as being sort of the overarching theme as well.
Yeah, I was lucky. It was easier for us to do because I kept growing up in communities where everybody was doing that.
Yep.
Because we would go from military base to military base, and everybody on the military base was moving the same sort of baseline. So we all knew and accepted that. We'll talk about a moment. I finally went to a public high school for grade 11. And it was the first time I'd met anybody who had actually lived in the same house their whole life.
Oh, wow.
And that concept just blew my mind. Was going, how could you not be bored with your life? Can you close your eyes and count all the steps to the store? Like, how do you not? The whole concept of just living in the same spot your whole life was so foreign to me and everybody I ever knew that it was just okay.
I guess they say you can do it in your sleep. It takes on a brand new meaning.
Yeah.
No, that's fascinating. And so embracing that constant change, being in those different companies at the moment of big change as well, which have been challenging, would certainly have built your resilience over time. But what was one of the most challenging situations that you've ever faced in your career to date, and how did you overcome it?
An early one was, I talked a little bit earlier of being involved in that hostile takeover. And so these were two companies that had mines like next door to each other. Okay. Mortal, fierce competitors for decades. And Luscar was the smaller company, which managed to take over the larger one.
Yeah, wow.
Corporate headquarters were in the two major cities of Alberta. So rivalries to be all and end all.
Wow.
In the corporate takeover, everything was being relocated from Calgary to Edmonton. And there was a whole group of people who were not wanting to do a relocation, but we had to train new people to do their functions. So my role in this piece was to learn from the existing people on what that they did, so to be able to train a new one.
Uh-huh.
The part is everybody knew they were leaving, and their severance packages were attached to me figuring out that they were getting all the information so that we could train before we could let them go. So you had all kinds of interpersonal dynamics of some people were completely pissed that they were losing their jobs. Some wanted to be out right away. Some were uncooperative. So it was all about learning those interpersonal skills to be able to get what you needed from these people so that you could move and do your job. So there was a whole set of learnings of saying, okay, well, if you're a hostile, well, I ignored you for a while and looked after this person. So had them sit on their thumbs and to push, or so every person had to have a different tactic to get the most out of them. So that ability to learn that side of dealing with people was very challenging, but ultimately gave me a lot of understanding and value.
I guess given the time limit, the situation, and then you being thrown into that role would have been very daunting when you just think about, the diversity of people and also the emotions. And
to put it as a part, I was in my mid-20s, so I was young.
Oh, wow.
Dealing with a lot of times, long-term employees that, this young kid coming in to do this was a whole other dynamic.
That's insane. And I guess, as you said, taking that more systematic approach, being able to quickly identify, I will talk to later, and I will try and maximize, I guess, the efficiency of how to get that information in the short term was probably the best way out. I certainly could not have imagined a better way to deal with that. And That sounds challenging.
Yeah.
But thanks for sharing. It's a very interesting and also, good reflection of, I guess when situations like this occurs, it's the interpersonal relationships that then become the really important aspect to make sure that things move peacefully. So what advice can you offer to young accountants, young experts in this field, in the mining, young people who want to make the environment a better place through recycling, through regeneration? What advice can you offer them?
So on young professionals, I'll go back to what I had said earlier, that there is no wrong questions. And it is about learning more. And if you keep in your little silo, you will only ever be limited to where you could grow. Your growth has to come by broadening your horizon. And you have to be able to understand more than your silo to be able to move forward and advance in places. And you only be able to broaden by talking and questioning and learning. So it's the mantra of continuous learning. Isn't just about courses. It's about understanding more things than your little area of operation. And I'll say that also applies to the broader sense of recycling, regenerating, is you have to understand more. You have to understand what companies, what processes are out there to how you can help make things improve. Because things don't necessarily come to you without you seeking them out. And if you seek out, it opens up opportunities that either can be good for you professionally or personally. So it's like everything. You have to seek stuff to improve.
Yeah, such great encouragement. And in a way, gives me confidence that I know the decision to go broad and to work interdisciplinary as well. And the things I do has definitely been paying off. And I'm sure a lot of young professionals will find that incredibly inspiring as well. And we'll put that to practice. And so, Don, what would you most like to be remembered for?
That I've done good. That people have liked me, have enjoyed working with me, that we are able to move forward projects that have done added value to the world. So those are it's simple things. I mean, I'm not looking to be on a plaque on a wall someplace as a thing, but that I've done my part, and that the people who have known me have enjoyed being with me and enjoyed the time we've been able to spend.
And I certainly have, and have learned so much in just this short time. So no, I'm very grateful for a lot of the insights that you've given me, and a lot of the curiosities as well, which I'll have to pursue as I'm editing this episode. And I'll certainly be in touch with some questions in the near future. You can count on that.
Sure thing.
Yeah. But Don, as we wrap up this show, where can people find you if they want to get in touch?
So if you want to find out more about Regenx, our website is a great place to go. We've tried to put a lot of information that explains the industry on that side. And so that's regenx.tech. And if you're interested we're a public company, so we're always looking for people to invest and move us forward in that. And so we're traded in Canada as RGX and in the US as RGXTF.
Perfect. And I suppose they can find information of, getting in touch with you, and also hearing some other aspects about your work on some other shows, which we'll definitely put in the show notes, along with, the information about the company and a lot of the material that we've discussed today and the fascinating facts that you mentioned. But thank you so much for being on the show. Like I do with all my guests, I always give my guests the final message. So, Don, one last message for the listeners to take away from today.
Well, if I'd say anything, it's that you can do things if you pursue them. And so it's all up to you to try to move away from your comfort zone if you want to do something different.
Thank you very much.
Thank you. It's great to be here.
And that wraps up our electrifying, insightful, and fascinating episode with Don Weatherbee. To hear more about Regenx Tech, some facts and figures on eWaste and urban mining, or to just track the value of different metals on the stock market, check out the show notes for more information over at petermbach.com/podcast. And as always, thank you listeners for tuning into this episode and for your feedback and support. If you are enjoying this show, I would be incredibly grateful if you could share this podcast with your family, friends, colleagues, and even local automobile club. Subscribe or follow this podcast on Spotify, Apple Music, other podcast channels, or follow the LinkedIn group to stay up to date with the latest releases. If you're curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel Peter Marcus Bach, that's Marcus with a C, or follow me on X at Peter M. Bach or Instagram at petermbach87. Feel free to reach out to me with any feedback or guest suggestions so that I can keep improving this show. The podcast's intro and outro song is called Starsky by Alex Kieran. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.